Welcome back to The Explainer. I am your host, and today we are doing something a little bit different. We are opening up the Insider's Playbook, and we are stepping directly into the examiner's vault. Think of this like a video game where you're the lead game designer, and you need to understand exactly how the physics engine works under the hood to win. Today we're tackling one of the most notoriously tricky areas across the entire Cambridge syllabus, calculating bitmap image file size. Now, whether you are sitting for the Advanced AS and A-Level Computer Science 9618, or maybe you're tackling those foundational concepts across the IGCSE and O-Level syllabuses like 0417, 0478, 0983, 0984, or 2210, listen up. This explainer is your ultimate guide, because here's the harsh reality. Most students lose incredibly easy, fundamental marks on bitmap calculations. They just throw them away. But after we go through this today, you are absolutely not going to be one of them. I'm going to show you exactly what senior examiners are looking for, literally line by line, so you can level up your answers and guarantee those top-tier marks.
Okay, so let's quickly look at our battle plan for today. We'll start with the challenge to understand exactly where candidates go wrong. Then we'll unpack core principles and peel. Next, we're going to unlock the method mark strategy, test your skills in an interactive workshop, and finally wrap up with direct examiner alerts.
All right, let's jump straight into section 1, the challenge.
Okay, I want you to close your eyes for a second and imagine this. You are in the exam hall. The clock is ticking down, the tension in the room is high, all you can hear is the scratch of pens on paper, and you turn the page to face a massive, complex past paper question on calculating a bitmap image file size. Now, you've studied the textbook, you know what a pixel is, you know exactly what color depth means, you even know the core formula, right? Image resolution, which is width times height in pixels, multiplied by the color depth in bits. Let's say the paper gives you a 1920 by 1080 image with a 24-bit color depth. On the surface, the math is straightforward multiplication. Yet when you sit down to extract the binary representations and actually perform the calculations, panic sets in. You freeze. Let's look at two typical traps students fall into in this exact moment. First up, we have Alex. Now, Alex overloads the answer with raw computer science facts. They do a massive brain dump, writing down every single definition they can remember about bitmaps, pixels, and metadata. It looks impressive, but they provide absolutely zero analysis of the actual scenario. The examiner's red pen just slashes right through it. No marks. Now, contrast that with our second student, Sam. Sam rushes straight into the math. Sam completely misses the specific command word requirements of the question. They perform the calculation of resolution times color depth perfectly, but they fail to actually evaluate or draw the evidence-based conclusions the prompt specifically asked for. So both of these students know the raw facts, right? But both of them completely miss the mark.
So what does this all mean? Why exactly do top students who know their stuff, lose marks on simple bitmap calculations? I mean, if it's just math, why is it so incredibly difficult? The answer, straight from the senior examiners themselves, is that the issue isn't the arithmetic at all. The real challenge is applying these concepts to completely unfamiliar contexts. Cambridge exams don't just want you to act as a human calculator. They demand logical, structured reasoning. They want to see a clear demonstration of how fundamental principles transfer to the unique, specific scenario given in the paper. If the question is about a game designer optimizing assets, you have to frame your math around game design, not just floating numbers.
Make sense? Good. Let's move into section 2, core principles and the Peel framework, to see what top-performing students are doing differently.
The Cambridge syllabus is actually incredibly clear about its academic benchmarks, but so many people miss it. On one side of the spectrum, we have superficial breadth. This is your standard, run-of-the-mill rote memorization. It's spitting out generic details. It's exactly what Alex was doing in our earlier example. But Cambridge doesn't want that. Cambridge prioritizes analytical depth. This requires logical reasoning, precise definitions, understanding causal relationships, and critically, this is a big one, making cross-topic connections. Top-performing students don't just memorize isolated facts. They exhibit a connected, conceptual understanding. In fact, principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. It's like a giant puzzle, and they want to see that you know how all the pieces fit together.
So, how do you practically achieve that analytical depth when you're staring down a blank page? You use the Peel framework. Point, evidence, explanation, link. This is a highly structured approach that literally forces your brain to align your answer perfectly with the higher-order assessment objectives. First, you make your point. Then you provide the evidence from the binary representations or the specific data provided in the prompt. Next, you thoroughly explain your calculation. And finally, crucially, you link it back to the specific context of the question. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, welcome to Section 3, the Method Mark Strategy. This is the procedural heist portion of our explainer. We are going to shift gears now and look at exactly how to build a winning, mark-securing answer step by step, even when the math gets incredibly complicated. To build a truly bulletproof process, you need algorithmic thinking. You have to approach it like a machine. Here is your standardized sequence. Step 1. Deconstruct the question and extract the relevant data. You need to actively identify the key given elements like width, height, and color depth. Pull them out of the paragraph. Step 2. Select your analytical framework and the appropriate data structures. Step 3. Execute the analysis with crystal clear notation and correct terminology. Don't just hastily scribble a final number at the bottom of the page. Show the step-by-step decomposition of your thought process. And Step 4. Verify your results. Check for reasonableness. Does the final file size actually make sense for a single image? If you follow these 4 steps, you are actively demonstrating the exact algorithmic thinking that examiners are hunting for. So, the absolutely crucial point here is captured right in the definition of the method mark strategy. Listen carefully, because in Cambridge 9618, and frankly across the entire computer science syllabus, marks are heavily awarded for the process. By showing your clear, logical processing steps, your step-by-step decomposition, and your efficient execution, you earn partial credit. Even if your final bitmap file size calculation is incorrect because you made a minor arithmetic error under the pressure of the clock, documenting your exact procedure guarantees you harvest those method marks. Never ever leave the examiner guessing how you arrived at your answer. Spell it out for them.
Now, if you struggle to retain these data structures and analytical frameworks, try using a visual story method. Imagine the bitmap as a physical grid in a story, right? Where every single pixel is holding a specific weight in binary. Visualizing it this way helps your brain lock in the procedure for the exam. Speaking of locking in strategies, stop scrolling. Subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's put all this theory into practice. Welcome to Section 4, the Interactive Workshop. We are going to kick off an interactive segment right now where you have to engage actively with me. I'm going to put you on the clock to extract core trends and spot fatal flaws. Let's see what you've got.
First things first, lock this problem-solving sequence into your mind. To evaluate alternatives and compare approaches in a high-level exam answer, you must use a deconstruct, solve, evaluate method. You identify the given info, you break it down into logical steps, you solve systematically, you check for reasonableness, and finally, this is the kicker, you make justified recommendations. You are going to need these exact critical analysis steps for the speed challenge we are about to do.
All right, take a look at the screen. Can you identify the fatal flaw in this data extraction? Imagine a student has done the comparative analysis, they've written a whole paragraph, but they completely lost the mark. Why did that happen? Well, if I am the examiner and I'm analyzing a flawed paragraph, I am specifically looking for similarities and differences. The fatal flaw here is almost always the lack of comparative connectives. A student might list the traits of 2 different bitmap resolutions perfectly, but if they don't explicitly use connectives, words like whereas, however, or in contrast, to support each comparison with evidence and draw a solid conclusion about their relative importance, the mark is just gone. The flaw is simply stating facts without drawing an evidence-based conclusion. You have to connect the dots for the examiner.
Which brings us nicely to our final synthesis in Section 5, Examiner Alerts and the Blueprint. We are now unlocking the specific, highly guarded warnings taken directly from the principal examiner reports. These are the exact pitfalls that senior examiners see candidates fall into year after year after year.
Let's rapidly fire through the top 3 warnings from senior examiners. Warning number 1, answers are often way too vague. Examiners want precise, specific, technical details. They do not want generic waffle. Don't write a novel, write a technical specification. Warning number 2, students constantly forget to check boundary conditions and edge cases when verifying their results. You have to test the limits of your logic. And warning number 3, answers are not specific to the context given in the question. This is huge. These traps are so incredibly easy to avoid, but only if you are consciously aware of them while you're writing in that exam hall.
And this brilliantly illustrates our single most important takeaway for today's explainer. The classic examiner complaint is providing generic answers that are not specific to the question context. You must always link every single point to the given scenario. Context is the ultimate decider for top-tier marks. Think about it. If the question is about calculating the bitmap file size of a highly sensitive medical X-ray versus a background video game asset, your final justified recommendations and valuations must directly reference that specific medical or gaming context. A medical X-ray has entirely different resolution and depth needs than a game texture. If you don't mention that context, you lose the points.
So here is your ultimate computer science cheat sheet. Lock in these 3 rules that guarantee top marks. Rule 1. Command word decoding. You need to know exactly what evaluate, compare, or calculate specifically demands from you. Rule 2. Peel framework application. Always use point, evidence, explanation, link to ensure analytical depth in your paragraphs. Rule 3. Time management matrix. Ensure you allocate the exact right amount of time to systematically process your data and check for reasonableness without rushing.
Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.
I want to leave you with this final provocative thought. When you sit down in that exam hall to tackle a complex bitmap image file size problem, are your calculations just isolated floating numbers on a page, or are they a justified recommendation built on logical reasoning and directly linked to the specific context of the prompt? The difference between those 2 approaches is quite literally the difference between an average grade and absolute, undeniable exam mastery. Keep practicing, keep applying that Peel framework, and we will see you in the next explainer.